Turn in. Turn in. Carter, how's the old football? Football in region? I think my nephew plays for PG, but maybe not their varsity, but nice. Nice. Thank you, brother. Geometric, guys. Last time we talked about arithmetic. Is that okay? Can you guys read that? I know it's not ideal, and I'm really sorry, but I've tried. But we just gotta still gotta. This I forgot to record this morning, so you guys are my recorder. What up, Tom? Ah, shiznit. Tommy, why you gotta be like that, brother? You're awesome. Thank you for helping me out. So, 12-3, geometric, okay? Last time, arithmetic, what made something arithmetic? We added or subtracted the same number, right? So geometric, what do you guys think this is going to be? Multiplying or dividing the same number. Here we go. So let's say I had 3, 1, negative 1, a third, negative a ninth, dot, dot, dot. Okay, is this a geometric? What is happening? I'm not dividing by 3. I am dividing by negative 3. Another way to say dividing by negative 3 is, say, our rate would be timesing by negative 1/3. If you ever see dividing by 3, that means it's timesing by a third, by its reciprocal, right? Is everybody there with me? Now, last time I gave you your basic equation in arithmetic. Now I'm going to give you your basic equation or your generic equation in, thank you, geometric. A sub n is a sub 1 parenthesis r to the n minus 1. That is our generic form. So, just like we saw last time, adding or subtracting the same number over and over again made it linear. So if I'm timesing or dividing by the same number over and over again, I get a exponential. I get an exponential growth or an exponential decay. Okay? Is everybody there with me? Any questions? I really like the hair. Want to know what it reminds me of, though? Beauty school dropout. Because she came out with pink hair. Never seen Grease? Hold on. Recording. Okay, A sub 1. Okay, we see our R. Who's our A sub 1? 3, right? R is negative a third. N minus 1. Now, could I find any term now?
Yes.
I could, couldn't I? Any questions on how to do that? Yes, ma'am.
So if I were to do that, the order that I would do is I plug in say 1 for n, so then I do negative 1
0. And what's anything raised to the 0? 1 times 3. Does that make sense? Now if I plugged in 2, which 2 minus 1 is negative a third. 2 minus 1 is 1. Negative third to the first is negative a third. Negative third times 3 is negative 1. But I could find the 5th term, the 80th term, whatever term I wanted, right? Now understand, as you get to bigger terms when you come into geometric, they get really big or really, really small. Because that makes sense because they're dividing, so they're getting smaller and smaller and smaller and smaller and smaller. Or timesing, growing really fast. Does that make sense? So anything really like almost past 10 is going to be a big number. Okay, any questions? Now, remember on the last one, when we did arithmetic, I gave you one like maybe a sub 3 was 64, and a sub 6, or the sixth term, was, let's see here, 8. Okay, now here obviously, just like I did last time, I have to tell you it's a geometric, because if it's not, then I can't tell. Because I only have two terms and they're not back to back to back, so I can't see that they're timesing. So they would have to tell you it's a geometric sequence. Does that make sense? But maybe they want you to find a sub 10. Okay, that's our goal. Find a sub 10. Well, with these two things, just like last time, we found slope. Well, with 2 points, hey! Hey! You forgot?
No, I didn't forget. I just couldn't come up with my mom.
Why don't you? I like food too. I had sandwiches. Where'd you go?
Just one before.
Some one walkage. I like their crispy beef.
And then we also got
Wontons. Gotcha. All right, so here's how we do this. Now, last time, there was an equation for slope. Ladies and gentlemen, there is kind of an equation for here. What we need to do is, what's the difference between a sub 3 and a sub 6? How much? 3 terms. Okay? And here, actually, I'm not going to do this way. I'm going to do it the way that I always do it. I was going to try to show you a shortcut way, but screw it. I'm doing it my way. Doing it my way. Okay, so if I know a sub 3, I could go a sub 1 to the r. Actually, let's change that 3 to a 6, because we have the 6. And then this would be 6 minus 1, because I replaced the n with a 6. Do you guys see what I did there? Because remember, our equation was a sub n equals a sub 1, parentheses r to the n minus 1. So I just put in 6 for n, so therefore up here I put in 6. Does that make sense to everybody? Yes, no? So therefore this is saying a sub 6 equals a sub 1 to the r to the 5th, right? Do you guys agree? Now what's the other equation we have? A sub 3, now why am I dividing it? You'll see in just a moment. Equals a sub 1 to the r. Now what's 3 minus 1? 2. Now why do you guys think I'm dividing this? When I divide it, those guys get rid of each other. A sub 1s would cancel out, wouldn't they? But notice I have r to the 5th over r squared, and when I'm dividing like terms, what do I do to their exponents? Subtract. So this is r cubed. Now, do I know what a sub 6 is?
Yeah.
It's 8. Do I know what a sub 3 is? It's 64. So what's 8 divided by 64? 1/8. Does everybody understand how I've got where I'm at so far? All I did is put information into the basic equation. Now, see you later, alligator.
Can I please get Allison Sorensen down to the attendance office for checkout?
You sure can! They never answer back to me. Tell them, if you go in there, will you answer Mr. Roberts back next time? No, see you. There we go. Want me to show you, just for you? So this is r to the negative 3 equals 8. Right? This is r cubed equals 1/8. And all you would have to do is here I would take the cube root. Over here, what would I do? Take the negative cube root. Which is 1/2. Which is 1/2. Would you like to see where you'd put that in your calculator? Now, which kind do you have? Show me what kind. Okay, so that's very similar to the TI-84. Okay, so you would see this, oh, we don't have it right here, but you have one right above your caret sign. Look above your caret sign. Do you see the x square root?
Yeah.
Okay, so mine's right here. So what I would do is go -3. So put in -3. Now mine's in this math, but go to that x square root for you. See how I have the x square root? See, now I made it -3. I put it in there, but you just have -3x square root, and that -3 just goes up into that x. So now put in 8 and see if you get a half. So here's what you need to do. So on yours, for your calculator, I get what's happening. What you need to do is go -3 in parentheses, then do the x square root. Try that. Okay, does that make sense?
Yeah.
Either way would still get us there, okay? Does everybody understand how I got r was 1/2? Now, is that my equation? Is r 1/2 my equation? What else do I need to know? I need to know a sub 1, don't I? Well, I go back into one of my equations. Do you guys care if it's a sub 3 or if we use a sub 6? Do you guys care? Say no, because it doesn't matter. No, Mr. Roberts, let's use a sub 3. So that's 64 equals a sub 1, which I don't know. But do I know my r now? What's our r? 1/2. And then notice that would be 3 minus 1, which is 2. Does everybody see where I got that information from? Once again, this was coming from our basic equation. Right? Could I use the 6th one? If that was the case, you'd go 8 equals a sub 1 to the 1/2 to the 5th. And I'll show you, I'll get the same result. So what is 1/2 to the 2nd power? Anyone? 1/4. So how do I get rid of timesing by a 4th? I times by 4 to both sides. So a sub 1 is 256. Now let's check it over here just to show you it doesn't matter which equation to pick. So I have 8 equals a sub 1 times 1 over, in this case, 32. So how do I get rid of that 32? Times by 32, and 32 times 8 is 256. See how either way it gets us back there? So now I have my generic because I have a sub n equals my a sub 1, which is 256. Do we know our r? What was our r? 1/2 raised to the n minus 1. What was my real idea that I wanted to find, though, today? I wanted to know a sub 10. So what am I going to do? Plug 10 in for n. To the 9th, because 10 minus 1 is 9. 2 to the 9th is, I have no idea. 2 to the 9th, oops, clear. 512. So a sub 10 is 256 over 1 over 512. Which this all comes out to be 1/2. Okay? That's a long process. You guys want to try another one? You guys ready for another one? Okay. Alex, can you hand me that book over there, please? That's right in front of you. Beauty school dropouts. You gonna go home and tell mom? Okay. Beauty school dropouts. Okay, here is this one. A sub 4 is 63/4. So this one's not as nice. A sub 7 is 1701/32. Okay? Now, what we're going to do is the same process. Right, Bridgie Bill? Right, thing 1. What's your favorite drink of choice? Yeah, me too. All right, here we go. I always like to do the higher number on top. And the reason being is like A sub 7, so that when I divide it, I don't have a negative power. I just have the regular 3, and then you wouldn't have had that mistake with the -2 or the half. Does that make sense to you? So if I always do that and I subtract them, then I'll always have a positive number, and then I don't have to worry about a negative root. Answer your question? So I have A sub 7 equals A sub 1 R. We're finding the general equation. Because then that general equation allows us to do what? Find anything, right? Does that answer your question? It's the nth equation, exactly. Okay? R, what power will we be? 7 minus 1, which is 6. Divide that by A sub 4 equals A sub 1 R to the third. Now, is it always, when I divide this, always going to be R cubed? No. Those, though, will always cancel out. And how I got 6 and 3 is because, remember, in the basic equation, it's n minus 1. Hi, Mr. Luke. The coconut? Yeah. Anyway, A sub 7 is 1701. Divide by 32. Divided by 63/4. Okay? Now, how do I go ahead and divide when there's two fractions? We times by their reciprocals. So I get 4/63 times 1701 divided by 32. I know that 4 and 32 go into each other. That's 1/8. Can somebody in their calculator go 1701 divided by 63, please? It was perfect. It's 27. So there's a 27. So R cubed is 27/8. Any questions on that? No problem. Please don't muster it around. Catch up. It's a dad joke. You're like, I could tell. Now I'm going to take the cube root. I could do this in my head because I know perfect cube roots. I don't know if you do. So this is 3/2. Okay, now we're not done. That's just one part of our equation, isn't it? Correct? Who else are we missing? A sub 1. So therefore I go into either of the two equations. I'm going to use this one just because I like 63/4 more than 1701 32. Does that make sense to everybody? So I have 63/4 equals a sub 1 parenthesis 3/2 cubed. So then that's 63/4 equals a sub 1 times 27/8. How do I get that 27/8 to the other side? What do we do, guys? We're going to times by 8 over 27, right? So we can get rid of those. Now watch what happens here. 8 divided by 4 is 2, right? What does 63 and 27 both share? What do you think, D-Clan? They share 9s. So this is 7. This right here is 3. So therefore, A1 is 14/3. So our generic equation, a sub n, is 14/3 parenthesis 3/2 n minus 1. What does that allow us to do now? Find anything we want, right? Is everybody okay with those? Any questions on how you would go about that? I don't think there's any more in there. I heard you sucking all the air. Okay. So the next thing we're going to talk about, just like we did with arithmetic, we did a sum of that sequence, didn't we? Okay, so let's say I have this. If I had 1 plus 3 plus 9 plus 10, could I find that really easy? Not 10, I don't know, I did 10, sorry. Should be 27. Could I find that really easy? I could just add that up, right? Even in my head. Okay, but this is called something that we need to know, which is finite. Anybody know the definition of finite? It stops, meaning there is a specific number where it stops. Okay, you're going to be learning a finite and an infinite. Now you might be saying, how do I add something that goes to infinity? There's only one case that will. Okay, and I'll show you how to do this. Well, here, like I just said, if it is a geometric sequence, or in this case it's a series because we're adding, right? I could just add that up. That's really quick. That's 40, right? The sum of those 4 terms is 40. But I'm going to show you what a finite is. So you're going to do S of n equals a sub 1, or what is another name for a sub 1? Beginning term, right? Doesn't necessarily have to be a sub 1, right? Sid, how in yours it started at 0, right? Remember, a sub 1 is really standing for the beginning term. Okay, parenthesis 1 minus r to the n over 1 minus r. There's no cool mathematician story here. Let's go ahead and find this sum doing our formula just like I did when I added it up. This should be 40, right? Let's see if we can get the same response and the same answer, okay? So here we go. A sub 1. Who is our first term? 1. 1 minus, what is our r? How are we getting from 1 to 3, 3 to 9, 9 to 27? Multiplying by 3, so our r is 3. How many terms did we use? 1, 2, 3, 4. Is everybody good with 4? Over 1 minus 3, which is The 1's nothing really out here. 1 minus 81 over 1 minus 3, which is negative 80 over negative 2. And what do we get? 40. So, if it has a specific ending point, we can find a sum for any of them that's ending. Okay, but infinite cannot. Think about last times. If it went on to infinity and we're continually adding the same number or subtracting the same number, what would that add up to be finally if it went to infinity? It would add to infinity, wouldn't it? It would keep going on. Or it would subtract to negative infinity, correct? Well, the same thing here. If I kept going with this pattern, wouldn't this go to infinity? Okay? So when it is infinite, I'm going to use this formula. Infinite only happens in one case. There's only one case that it can be happening. Your R value, the absolute value of it, has to be less than 1. And I'll explain why. Remember, this is an exponential decay if your R is less than 1, isn't it? So once again, that graph looks like this. So as I get closer and closer and closer to infinity, what happens? It's getting closer and closer to what number? 0. Think about a half raised to the millionth power. That's so basically 0, we can't stand it, right? It's like 0.0000000000005. There's so many zeros in it, it's basically 0 though. Does that make sense to everybody? So the only time we can do infinite is when your R is less than 1. Your rate is less than 1. Now when I'm saying that, it's the absolute value, because like negative 2 would not get me there, because the absolute value of it is not less than 1, right? So it has to be like 2/3, negative 4/5, things like that. Okay? So let me show you how we get the formula for it. What was our finite formula? A sub 1, 1 minus r to the n over 1 minus r, correct? But once again, if my rate is less than 1 and I raise it to a very large number, what does this basically become? 0, right? R raised to a very large number, that's very good. If it's less than 1, it's basically going to become 0, isn't it? So what's 1 minus 0? 1, and what's a sub 1 times 1? So our finite is a sub 1 over 1 minus r. Okay? Yes, no, we're almost done. So, let's see what we have here. Let's do one that's in summation notation. N equals 2 to infinity. If I have 5, negative 4/5 to the n minus 1. Okay, so first off, we got to make sure it's geometric. How do I know it's a geometric equation? It looks like a exponential. Okay? That's how I know it's by an exponential. Am I really that boring? You guys all look like you're bored as hell. I'm really sorry. I'll work on it.
It's just math.
Oh. Math builds the world. Touche, buckwheat. Okay. So, this isn't infinite. So we have to make sure our R value is less than 1. Is R, which is negative 4/5, the absolute value of it less than 1? It works, doesn't it? Okay, so this is an infinite. So remember, let's write our formula. S of n is a sub 1 over 1 minus r. Now once again, what does this a sub 1 represent really? The beginning term. Okay, beginning term. So who's our beginning term in this case? So I'm going to plug 2 in. 2 minus 1. 1. negative 4/5 to the first power is negative 1. Negative 1 times 5, negative 4. Over 1 minus a minus 4/5. Want me to go back up? No problem. So if I plug in 1 right here, or 2, excuse me, because I start with 2, with me? So 2 minus 1, negative 4/5 to the first power, negative 4/5. Negative 4/5 times 5, that's negative 4. Answer your question? Okay, what does a minus minus become right here, ladies and gentlemen? Becomes a plus, so this is 5/5 over itself, right? 5/5. So that's negative 4 over 1/5. Nope, 9/5. Does everybody understand where I got 9/5? 5/5 plus 4/5. What do I do there now? Times by its reciprocal. So that was negative 4. The reciprocal was 5/9. So I come out with the sum of infinite terms for that equation is negative 20/9. That's what it'll add up to be. I can. Right there. Huh? With the dam? Somebody did, yes. They're like, look, I'll be damned, and they're in hell, so that's being damned. We're having a good time over here. Somebody wants me to be on a donkey so I can and kick my... It'd be my swear wall. Anyway. Are we ready? Do you guys want another one? Or can I do the story problem that kind of does the same thing? Okay. So, how many guys have ever seen a ball bounce? What happens? So let's say we start at 100 feet. So we're really on top of a building. How high? Let's say it returns 2/3 of its, actually let's do 2/5. Do 2/5 of the original amount. What does that mean? So it's going to come down, boom, and then what's going to happen? It's not going to go up, it's only going to go 2/5 of that original height, right? Okay, just bear with me here. So 100 feet times by 2/5, this height right here is now 40. That does too look like 2/5 of it, jerk hole. Yes, it does. And then it bounces again. What's it 2/5 of this time? 2/5 of 40, which is 16. And it keeps going bounce, 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 bounce. You guys all understand that, right? And then if we were in a perfect vacuum, in a perfect level room, would that ball ever stop, technically? If it had no friction or anything like that? It would technically never stop because it's technically bouncing, but we just consider that rolling. But it's so small, it looks like it's just rolling, right? Does that make sense what I'm saying? Because it's so small, because it's half of a half, a fourth, an eighth, a 16th, a 32nd, and so on. Right? You get what I'm going there? Okay. So what I want you to do is find the total distance it traveled. How much distance did it travel? Okay, so let's set up our equation first, shall we? Well, notice, ladies and gentlemen, if we start adding, this is 100, but this is climbing 40, and then what else does it do? Goes down 40. Climb 16, goes down 16. So we actually have to times everything by 2, and then what should we do? Subtract 100. So let's find the sum of all the bounces, okay? Who's our a sub 1? 100. Over 1 minus, what's our rate? 2/5. So right there, guys, that is 100 divided by 3/5, which is 500 thirds, which I don't know what that is really. Can somebody tell me what that is in their calculator, 500 thirds? It's 166.7. I think. Somebody do that? Yeah? Well, that doesn't make sense that it travels 166.7. It travels 180 after that one bounce, right? Once again, what do we need to do to that? Times it by 2 and subtract 100. So then that would be 1,000 thirds minus 100, which is now traveling 233.33 feet. Does that seem a little bit more realistic? It does, doesn't it? Because once again, it's going to get so much that it really isn't adding anything on top of it, does it? Okay. One last question and then we're done. I don't know why it's in here, but it's in the freaking unit, so I would pay attention on this one because I don't know if it's going to be on the test. I don't know. You guys know what's a rational number? A number that can be written as a fraction. Can decimals be written as fractions? What? Only if they do what? If they stop or if they repeat. If they stop, so like if it's like 0.125, I can quickly make that into a fraction by saying that's 125 over 1,000. Right? Because there's 3 decimal places behind it. That's pretty simple. But how do I know? You guys all know that 0.3333 and so forth, right, is 1/3. Do you guys agree with that? But how is it 1/3? Well, let me show you. I'm going to call this 1/3 x. How many times or how many spots do I have to move my decimal to get past the repeating on the right side? I only have to times it by 10. Because when I times this by 10, I get 10x equals 3.3333. Do you see how I just moved my decimal one time to get past the repeating? Watch what happens. What's 10x minus x? Good. What's 3.333333 repeating minus 0.33333 repeating? It's just 3. I got rid of the repeating stuff. So then, divide the 9 over, we get x is 3/9, which is who? 1/3. Pretty interesting, really, if you think about it. Right? Should we do a harder one? I'm going to do a harder one. Let's say x equals 25.2131313 repeating. So what you want to do first is notice right after decimal it's not repeating, isn't it? Does everybody get that? So what you have to do first is multiply to get to the repeating part at the decimal. So how much do I need to multiply by? How much? 10, right? So then I get 10, ooh, okay. 10x equals 252.1313 and so on. Now if I subtracted this and this, would I get rid of the repeating? I would not. So I have to do it again. How much do I have to times by to get past the repeating? I got times by 100 because that's 2 decimal places. Does that make sense to everybody? I'm timesing this guy right here by 100, which is 1,000. Which would be 252.1313 and so on repeating. Now why did I do that? Because beforehand I couldn't subtract those. Now can I subtract these two together and get rid of the repeating decimal? Once again, I don't know why this is in this unit, but it is. So I get 24 962, I want to say. Nope. 961. Can somebody do 25, 213 minus 252? Let's see. Oh, there's my quick fingers right there, Al. Did I get 24, 961? Go 25, 213 minus 252. Yeah? All right. I did some math today. What's 1000x minus 10x? 990x. Go ahead and divide by 990. I don't know if this reduces, but is it written as a fraction? It's pretty cool to see. That's how they get repeating decimals to put into a fractional form. Anybody ever know that? That's how they get the fractions out of that? Anybody seen that before? You have? Okay. So your homework is 12-3, 1 through 67 odd, 80 and 81. Okay?